Greetings. My name is Bret Stateham. I'm a Microsoft technical evangelist, and I'm coming to you today from my lovely garage and shop out in San Diego, California. So I hope things are well wherever you happen to be. And in today's session, I'm going to go over a common issue sort of with IoT solutions, and that's connecting your devices in the field up to the cloud. And since I'm with Microsoft, we'll be talking about Microsoft Azure using field gateways. And at Microsoft, we've worked with a number of partners, including, in this case, Intel and Seed Studios, to produce a Azure IoT starter kit that you can use to help you create gateway devices that can connect with other devices in the field and then help publish that data up into the cloud, in this case, again, Azure. So let me, in fact, just kick it off here. I'm going to go ahead and jump over to my screen. And again, you can, well, actually, I'll share this with the event organizers so that these slides are available through there. But you can also download them from the URL that's will be on the bottom of most of the slides there. It's at aka.ms/IoT DevFest. And again, my name is Bret Stateham. Contact information is up there on the slide, so feel free to reach out if I can help. So we're going to go over a few things here today. First of all, I'm going to start out introducing the Microsoft Azure IoT stack. If you haven't taken a look at Microsoft Azure or at the IoT services in Azure, I think you'll find it's an extremely broad platform. And we've been in the IoT space for quite some time, even in the cloud. And so I'll sort of walk through some of the tools that we have in Azure to work with IoT and then sort of get a view of the overall Azure stack as well. Then we're going to come back in and I'll sort of introduce you to the Grove IoT Commercial Developer Kit. And again, this is a kit that we've developed in partnership with Intel and Seed Studios to help developers create sort of gateway solutions that can connect to devices in the field and help publish data up into the cloud. And then finally, we'll come back in and look at our gateway solution, Microsoft's gateway solution software layer called Azure IoT Edge. If you watched our build announcements, I guess that's now probably 2 or 3 weeks ago, this is sort of a new name around a previously released technology called the Azure IoT Gateway SDK. But basically, Azure IoT Edge is a set of software development tools to help developers create those gateways that run on the gateway devices in the field. And so we'll take a look at that. So starting out here, let's jump in and take a look at the Microsoft Azure IoT stack. And so at the heart of IoT and Azure is a service that we have called Azure IoT Hubs. And so if you consider that you've got some devices in the field, various microcontrollers and connected, actuators and sensors and, motors and all that good stuff. In the MCU, we don't really care necessarily exactly what that is in terms of we don't require it that it be something specific. We want to work with pretty much any microcontroller that's out there. And if you want to work with Azure IoT Hubs from those devices, we've got a variety of standard protocols that we support. That's AMQPS, MQTTS, or HTTPS. And I'm always very specific to call out the S at the end of those. It's not just AMQP or MQTT or HTTP. It's AMQPS, MQTTS, and HTTPS, implying that we require a TLS or SSL encryption layer on that traffic. Azure IoT Hubs does not allow insecure communications with it. And we'll find that actually places a little bit of a demand on the MCU that's in the field then, right? I need one that, first of all, has some kind of connectivity to the internet. It's got to get some sort of TCP/IP stack over Ethernet or Wi-Fi or something like that. And not every board out there has that. It also has to have enough compute power to do the TLS or SSL encryption that's required of Azure IoT Hubs, and that you really should be, doing anyhow for secure IoT data across, the public internet there. But if you can do that, if you can communicate with one of those standard protocols, you can send data up to the Azure IoT Hub. And not only that, you can also receive, I say data, but messages. So we have this bidirectional communication mechanism with devices in the field over these standard protocols. Every device in the IoT Hub gets its own unique set of credentials, its own identity that we can use to securely communicate with it, as well as to identify it. And that gives us also the ability then later on, if we feel that a device has been maybe compromised somehow, or if it's just being aged out, we can disable it or delete it from the registry of devices up in Azure IoT Hubs. We also have a bunch of other really cool features up in Azure IoT Hubs. We have a device twin capability where you can sort of describe the metadata of the configuration of the device, let's say, for example, in a JSON document, and then the MCU can periodically pull back up to the twin, find out what its property and configurations are supposed to be, and then affect those changes. The nice thing about that is that that means that you can make changes to your device's configuration even if you can't immediately communicate with the device itself. You define the configuration data in the cloud, and then it syncs up to that when and where it can. We also have the ability to call jobs or run methods that are exposed down the device itself. So for example, if the microcontroller had a temperature sensor on it, rather than waiting for it to push the temperature sensor value up to me, I could instead turn around and ask it, hey, give me the temperature value, run the job, generate the value, and send it back up to me there. So full, secure, bidirectional communication with devices in the field over those standard protocols, really powerful. But the other really cool thing about Azure IoT Hubs is that, as being the heart of this sort of platform from an IoT perspective, is that once you get there, you now have access to the entire rest of the Microsoft Azure platform. So we've got compute services, virtual machines, web applications, containers and microservices and serverless compute and all that good stuff. We've got databases and storage, relational, NoSQL, et cetera, globally distributed, highly scalable, et cetera. I use the term AI there really more just to sort of encompass all of the various, predictive or machine learning or, cognitive type solutions that we have available up in Azure. We've got BI with Power BI embedded, or just Power BI in general. You can do charting and reporting and dashboards and interactive sort of reporting solutions out there, et cetera, and so much more. And the way that those services consume the messages from your devices is, again, over a collection of open APIs and SDKs. So if you want to roll your own service, those APIs and SDKs are going to allow you to communicate both with by receiving messages from the devices in your IoT Hub, as well as being able to send messages back down to those IoT Hubs, and possibly even to manage the IoT Hub itself, create new device identities, manage them, et cetera. So this slide is, in fact, a little bit dated. The Azure platform grows, constantly, but hopefully this will give you sort of an idea of the breadth of the overall services that are available out there within Azure. Remember, I was saying that sort of at the heart of an IoT solution is that IoT Hub. And so, at least initially, we would consider the IoT Hub as a way to communicate with some of these other, analytics and IoT services. Some really popular ones in that category, Stream Analytics is a very powerful way to sort of watch the stream of messages that's coming in through an IoT Hub or an Event Hub or whatever, and then run transformative queries on those. We can take the message data and modify it if we need to. We can take the message data and simply replicate it off somewhere else. We can also make decisions on where that data should go based on what those values are. And we get to do that with a very simple or familiar SQL-like syntax as we define those stream analytics jobs. And we'll see one of those come up here in a demo. Some other great ones in there, though. You notice we've got, data lake for storing large volumes of data. As you get into large IoT solutions, you have lots of devices with lots of sensor data being published. We need a large data store to be able to keep that stuff in. Machine learning for doing predictive analytics and a whole bunch of other cool stuff. But we also now have the ability to get out to all of those other Azure services, compute and storage and, mobile applications and web applications and a whole bunch of really cool stuff that's available out there in Azure simply by getting our messages into IoT Hub from our devices, all the rest of this sort of, I always say that sort of the flower of Azure blooms and just opens up for you to use. I know that's a little corny, but okay. So you can learn all about Azure IoT Hubs. The documentation is up there on the URL on the slide. And again, you can grab the slides from the URL that's on the bottom of most of them, not on this one. And I'll also make sure that they're available through the conference platform here as well. But you'll notice on there, though, that we have SDKs and documentation for a variety of languages: .NET, C, Java, Node.js. And if there's not an SDK for your specific language, these services are all exposed via REST. So you can always just consume the REST services or create your own SDKs that effectively just wrap up those REST services. We also have a suite of command line tools. In fact, there they mentioned the Azure CLI 2.0. So that's another option that you have for managing the resources. So that's admittedly a pretty brief look at the Azure stack. We could spend a week on that, or a month, or a career. But we'll, just for the purposes of this presentation, jump over and take a little look at the hardware side of things. So I mentioned in this scenario, I'm going to be using the Grove IoT Commercial Developer Kit. This is actually just one of many Azure IoT starter kits that we've created in collaboration with a number of other partners, including Adafruit and of course, Intel. So in fact, in this case, we'll be taking a look at sort of the Intel NUC Azure IoT Starter Kit. So the Intel NUC is effectively a little mini PC that runs distribution of Linux. It's the Wind River Linux distribution on it, and it has a number of things pre-configured on it from Intel to help you create IoT-based solutions. So, in fact, this is a picture of the one that I have sitting next to me. I'll have the live camera view up here in just a minute. But the heart of it is this Intel NUC device running the Wind River Linux distribution out there. It's also got a number of, as I said, tools that we'll take a look at here, developed and deployed onto the device by by Intel as part of that image. And in this case, it's connecting over a USB cable off to an Arduino that's actually not part of the kit. You'll need to sort of add your own Arduino here, so to speak. But in this case, it's an Arduino 101. But really, the important part here is that we have a Grove shield. So the Grove format of devices is from Seed Studios, and it gives you this really easy sort of way to just plug in additional things like LCD panels or buzzers or rotary sensors or temperature sensors, etc. And the kits usually come with a whole bunch of other really cool things that you can play around with and easily plug them in. And so when you're looking at a prototyping perspective, especially I'm more interested in building the enterprise solution or the cloud stack side of things. Having to get in and even do breadboarding and certainly soldering and things can be a little bit of a time sink for that. So the Grove system makes it very simple to sort of prototype these IoT devices out there. And so, again, in this case, the NUC is communicating with the Arduino that has these sensors connected through the Grove shield over this USB cable. And what the built-in software does is when the Grove boots up, when the NUC boots up, it actually looks to see, hey, do I have an Arduino device over there off that USB connection? And if it does, it deploys a standard set of firmware onto the Arduino that implements the Firmata serial protocol. And that basically just gives us a standard way to communicate with a microcontroller over a serial connection. In this case, we're turning that USB connection into a serial connection there. And so now we can communicate with it serially, and we then have the ability to tell it, hey, there's some different sensors connected to different pins. And so in this case, the NUC is actually asking the Arduino to tell it, hey, what's the value coming off, the pin that the temperature sensor is connected to, or send a value out to buzz the buzzer, et cetera. So the Arduino in this case is really more just of a proxy, and the NUC is actually doing the bulk of the work in this case. And we'll take a flip side of that in a little bit and look at where the device itself may actually be the one that's really sort of controlling the data coming out. All right. So I mentioned there's a number of tools that are pre-deployed onto this NUC from Intel. And one of the most obvious ones is an IoT Gateway Developer Hub. So this is actually a Python web application that's part of the distribution that deploys with the NUC. And so when the NUC boots, assuming it can connect to the network over Ethernet, it'll just typically DHCP out an IP address. And one of the other really cool things about this, in fact, if I flip back over here, you'll notice that the default, remember I said that it automatically deploys this Fermata program over here. It also automatically, if there is an LCD panel hooked up to the ITC bus there, it'll read the IP address from the NUC and actually send it down to the LCD display for you if you have that connected. So that's really nice if you have a situation where the NUC is up, but you don't have a screen and a keyboard, which in this case I've added a couple here. Those are my own. Those don't come with the kit. But the cool thing about that is the NUC will tell you, hey, here's my IP address, just by publishing it out in the LCD panel for you. So that's really nice to have that there. And so once I know that IP address, either by reading it from the panel or going ahead and hooking up a monitor and a keyboard and getting the IP address, by logging into the Linux subsystem, then I can actually browse over to the web application on that. And that's where I'll get this IoT Gateway Developer Hub web application. So there's a lot of cool things you can do in the Developer Hub. There's administrative tools to help you administer the NUC itself, as well as tools to install additional RPM packages. This actually uses the Smart Package Manager, which kind of wraps up RPM for you. But we also have sensors. So here's, again, sort of the benefit of having that Fermata protocol automatically deployed. There's a built-in solution that is actually listening internally on an MQTT bus of its own. And then the default Node-RED application, we'll see that in a second, that runs on the NUC, goes and publishes the value of a rotary sensor that it assumes is connected up over MQTT, and then the Developer Hub reads it and charts it for me a couple of different ways. I get this line graph and this little circular sort of progress bar, if you will. So kind of cool. And so that's, again, assuming that you'd hooked up the Arduino and the Grove Shield as sort of I have it configured here with the LCD panel on the I2C bus, and then at least this rotary sensor. It's not a very good picture of it here, but it's basically just a little potentiometer hooked up to one of the analog ports. It looks like A0 in this case. Then the Developer Hub will get those values and publish them out for you. And then I also mentioned Node-RED. So if you're not a hardcore developer, Node-RED is a really easy way to get into creating JavaScript solutions, and in this case, specifically around IoT devices. So in fact, this is that default flow. Remember I said by default, it's going to go find the IP address from the local machine, and then it's going to publish it out to the LCD panel that's connected. It's also going to read that rotary sensor and then publish those two values over in QTT off to this charts bus. So one is the line graph, one is the bar chart, and it publishes up to this MQTT panel. In fact, if I see this purplish color with the little, signal-looking icon on it, and I look over here and say, yep, sure enough, that's an MQTT node that got added in here. So this is my toolbox of nodes I can add. This is my workspace, and I can drag them out and add them there. So in fact, with that, I'm going to jump over to demo here, and I'm actually going to build a really sort of a robust solution, and that's because we've only got about 40 or 50 minutes here. So I'm not going to walk through it step by step. I've got this pre-built, but we'll show you what we've got. And this is really the beginning of a lab that you can download and go through yourself. It's up at github.com/dxcamps/Microsoft Intel IoT Camp. And in fact, if I jump over and go to that URL, so this is actually that URL. And if I jump into the HOLs for it, the hands-on labs, this is the overall architecture. And so you'll notice that over here on the left-hand side, there's that, let me pull that up bigger. There's the NUC getting out to the internet over Ethernet. We've got that Grove sensor and LCD hooked up over USB with a buzzer and a temperature sensor and a rotary angle, et cetera. And so the NUC is then going to take that data and publish it up into Azure. And so remember I talked about Azure IoT hubs. So this is sort of the heart of that system, and it's where I do that bidirectional communication with my NUC. So in my solution, I'll have an IoT hub. I'm then going to use Stream Analytics to read those sensor values. And what it's going to do is take all of the messages that it gets and send them off to an Azure SQL database that I can then display in a web application. It's also then going to take all the ones where the temperature is over a certain threshold amount and send them off to another internal message queue that I have called an event hub. And then that event hub, when those messages arrive, is going to trigger a serverless function. That serverless function will then send a message back down through the IoT hub to the NUC and say, hey, you're too hot, sound the buzzer, and show some information off on the display. And then I didn't implement it in this demo, but we also have Power BI embedded, and the lab walks through setting that up and doing some charting and things like that if you'd like to see that. So you can look into that if you're interested. I'll keep that handy there in case I want it. But with that, let me jump over to my camera and my screen. All right, so first of all, here's my camera. So this is my live camera here. And so this is my NUC, there's my hand. Hi everybody, yay. All right, cool. And that's basically the same picture that you were seeing earlier with my NUC. I've got the Grow Shield, the LCD, hooked up my own little monitor and keyboard, etc. there. And let me also then pull up, how do I want to do this? I'm gonna go ahead and pull up the browser. There you go. And in fact, if I look on the LCD there, the IP address that it's showing is this 192.168.2.24 IP address. And so you'll notice that if I just navigate to that, HTTP 192.168.2.24, that's where I get to this IoT Gateway Developer Hub. So I'm actually, from my laptop, which is just sitting right here, I'm just to the left of this, I'm coming over my local network and browsing into a web application that's running on the NUC here. And so this is that web application. And just to show you that it's live, here's that rotary sensor, right? It's really just a potentiometer. But as I twist this sensor, if you look back over in the developer hub, you can see the published sensor value being updated and changing the line graph and the rotary chart there that's showing up. It's also, in fact, updating the color of the LCD panel, right? So just depending on the range of the rotary sensor, it changes it to a couple of different colors as you rotate through there. And that's just another sort of visual clue that I can see that that stuff is working. And so the reason that stuff is all doing what it's doing is because of a default Node-RED flow. So on this developer hub, if I were to jump over to administration, I could actually come down to the tools and go into the Node-RED editor, but it kind of wraps it up in this developer hub frame. I'd rather just go directly there. So again, I can just go to the IP address, and the Node-RED server is listing on port 1880. So I can just go straight to port 1880. Again, this is browsing over to another web service that's running on this NUC over here. And so this is the Node-RED development environment as it rockets to the screen. There we go. And I've got a couple of different what are called flows. Think of a Node-RED flow as like a program. But this flow one is the default one. And this is the one that we saw earlier. It goes in and gets the IP address from the local machine and then publishes it out to the LCD. So that's that one. And this one actually runs every minute, I think. Yeah, so this is just a scheduler. It's going to run every minute. Gets the IP address from the local computer. And so what that one's actually doing is actually just shelling out, to the NUC and doing an inif config and finding the Ethernet port and then getting the internet address off it. And then it's writing that out to the LCD panel over that Fermata protocol. And it's telling it to, change the background color of the screen to blue when it does that. And it starts writing the IP address on the first row at column 0. First row, first cell, if you will. Cool. It then also reads that sensor and then changes the background color of the LCD based on that and then publishes those values off. So that's that default flow. So that's pretty cool. But I want to work with some stuff up in Azure. And I mentioned that the first thing that you've got to have in Azure from an IoT perspective is an IoT hub. So I can jump over here to the Azure portal. In fact, I'll just reopen it. HTTPS portal.azure.com. And this is where you would go to manage, at least through a browser-based interface, your resources up in Azure. We also have a command line interface. There's the Azure CLI that you can use from really any platform, Windows, Mac, Linux, whatever. And so I'm opening up the portal here. And of course, as demo happens, everything slows down. But this is the pre-configured solution that I have already set up in Azure. Hopefully that'll open up here quickly. Again, it knows I'm demoing, so it's going to take forever here for me. That's what I get for refreshing it, right? All right, well, while it's thinking about filling in these tiles, what we're seeing here is the dashboard in my Azure portal. In fact, there's multiple dashboards available. I've just got the one that I've already set up for the Intel Global IoT DevFest here. And then over here on the left-hand side, I have a way to go browse the different types of resources that are available, as well as to create new ones. So if I wanted to create a new Azure IoT Hub, I could just click on New. And then from the categories available, in this case, I want an Internet of Things. And again, my apologies for the speed here. All right, but here's Internet of Things. And if I open up Internet of Things, you'll notice we have a ton of different services available. IoT hubs and event hubs and stream analytics jobs and machine learning and notification hubs and a whole bunch of other really cool stuff. And those are kind of the services that were in that platform diagram I showed earlier under the analytics and IoT section there. But I could just come in, tell it, hey, I want to create a new IoT hub. And when I do that, I get to give my IoT hub a name. I get to tell it which data center we want to run it. With Microsoft Azure, we have data centers, over 30 data centers all around the globe. That's more than our major competitors combined. And so you can really sort of choose to run your services and store your data where you need them to run, or where maybe for compliance reasons you need them to be run, et cetera there. But so I can go through here, give it a name, pick the scale size and the pricing for it, et cetera here, and what data center I want it to run in, and then I can pin it off to the dashboard. And so I'd already done that. That's what those icons were back on that dashboard that loaded it up here when we first pulled this in, right? So in fact, here's the IoT hub that I created. And so inside there, inside the IoT hub, I now have the ability to manage the devices that I want to allow to connect. And so I have this device explorer here, which is a tool that I can use inside the browser to create device identities. So in this case, I've got my Intel IoT gateway device out here, this NUC, that's really going to be what's publishing this sensor values up for me here. And so I went ahead and just created a device identity here called the MIC, that's for Microsoft Intel Camp, DF for DevFest, Intel IoT Gateway. Now, in a real world scenario, this would probably be some big ugly GUID, or maybe something that matches a hardware ID that you're burning onto the device itself or something like that. But for demo, I've just given it a friendly name. And then remember, I mentioned that these guys have secure credentials that they use to connect. So every device has its own ID. It also has its own keys that it can use to connect. And then I can also enable or disable individual devices. I also mentioned the device twin, where you can come in and manage device properties. We can also send messages. We've got bidirectional communication, et cetera. So that's all pretty cool. I want to make sure not to take too long here because I've got some other stuff to talk about, so I don't want to get too carried away. But back over here then, I've got a number of other things. I've got a streaming job. And in fact, I've got a problem right now. And that, in fact, if I flip back over to my camera, if you look at the temperature, it's telling me that I'm reading a temperature value of 33.6 or something like that. And the problem is my Stream Analytics query is already set up to send me alerts if it goes over 32. When I was first testing this morning, it was much cooler out here in my garage. But since then, it's heated up. So I'm going to stop my Stream Analytics query here. And this wasn't planned part of the demo, but since it's bugging me right now, I'm going to go ahead and stop it. We'll tell it to stop the job. And that's going to tell it to just stop reading messages coming in out of the IoT hub. This thing's already configured and publishing temperature data. So in fact, this right here is the temperature sensor. So it's reading just the ambient temperature from here in the room. It's sending them up over the USB through the NUC up to my IoT hub into that MICDF Intel IoT Gateway device identity we just saw configured here. So the Stream Analytics job then reads those messages and sends them off to the SQL database or off to another hub I've built here called the Event Hub. And hopefully this thing will quit. Okay, cool. I can't edit the query though while the job's running, so I had to stop it. But now that it's stopped, I can come in and click on the query, and you'll see that what it's doing here is pretty straightforward. It's a simple SQL-like syntax. I mentioned that earlier. And what it's doing here is it's getting, any second now, as soon as it pops up, amazing with its speed and agility. Before we even know what happens, it pops up on the screen. There it is, cool. So there's actually two queries in this one. This one gets all of the messages coming in from the IoT hub. So get everything from the IoT hub and send it into the SQL database for me. And those are gonna go into a table where I get the device ID, that's that MIC-DF Intel IoT gateway, a timestamp that's generated from the device itself, and then the actual temperature value coming off that temp sensor there. The other query is gonna do the exact same thing, but it's gonna send them off into this alerts hub only where the temperature is greater than 32. Well, I'm already over 32, so let's bump that up just a bit. We'll make it like 30. I don't want to go too crazy. Yeah, I'll do 30. Let's do 35. I just don't want to have to fight to get it up there. So basically, if the temperature goes over 35, that's going to be what I consider to be an alert. And you could tie this into reference data here. I'm hard coding that, but you could have files with thresholds set in them that this guy goes out and references, et cetera, as you need to. But let me save that query up then. And we'll get that job running back over here. So close the query up. And then I can start my job back up. That'll take a minute or two to start, but that's good. So while that's doing that, let me jump back over to Node-RED. And so this is the flow that I developed for Node-RED. And so this is similar to what we saw before, although this time it's going to go read that temperature sensor. It converts it off to Fahrenheit for me, and then displays it off on the LCD. And so that's why over here on the LCD panel, I'm seeing the temperature come out. There's 33.66 coming out there. It then also creates the payload, the message payload that's going to be sent up to Azure. And so if I look inside that, I can actually see the JavaScript that runs. But here's the JSON that is publishing. In fact, remember my Stream Analytics was getting those values, the device ID, the timestamp, and the actual temperature sensor value. So that's why those values were available, is because this Node-RED flow is publishing them. And so it then goes and gets them all formatted up as data, and then sends it off to Azure IoT Hub as that device. So remember, the device has its own credentials. And so here I'm telling the Nook, hey, here's your credentials. Here's how you can act as that MIC-DF Intel IoT gateway device that I defined up inside Azure. And so that's kind of cool. It, at that point, sends them. Now, everything below here is what happens if it receives a message coming back down. And so we're going to assume that the message coming back in is a temperature alert. So we're going to check to see if the message type coming back down is a temp alert. And if it does, we're going to turn on the buzzer and show it off on the LCD over here as well. So that's kind of cool. All right, so that's my Node-RED flow. And again, you can develop these. The source code for all of this is available up in the GitHub repo that I pointed off to over there as well. And so that's why I can now actually see data coming in there. Now, the other thing that I built up in Azure, oh, I forgot to hit start. Dagnabbit, that's my fault. I think it heard me. There we go, starting the stream job. So that's my Stream Analytics job. Remember, I showed you the queries where I said it's going to get everything from the IoT Hub and send all the messages off to the SQL database, and only the alerts where now the temp is greater than 35 go off to this Event Hub. And then I've got a web application that I built that's actually listening on this micdfweb.azurewebsites.net. In fact, that's a live site if you wanted to go to that. So again, that's micdf web.azurewebsites.net. And so this is the actual one. So notice that the last sensor value is a little bit old. It's 11:50 a.m. my time, whereas right now it's 11:54 a.m. my time. And that's because I'd stopped the Stream Analytics job. Since the Stream Analytics job was stopped, it's not sending that data off to the SQL database so the web application can't see new data. So once this job gets running, then new sensor values will come in and the web application will start displaying them for me. So the other piece that I have is great. So it says the job started successfully. The other piece I have is this function that is set up to, if it sees a, oh, sorry, that's my service bus namespace. So that's my Venta. Sorry, clicked on the wrong icon there. These functions over here, these ones are then going to get notified when one of those alerts show up in the hub. And if they do, it's going to send a message back down to my device to sound my buzzer here for me. So we'll get this guy up here. Now, your functions that you can write, this is an example of serverless code. It's just a way for you to define code in a certain language. In this case, I used C#, but it could be Node.js, it could be Java, it could be Python, it could be PHP, whatever. But this one's going to go out and get the Event Hub message, which is those same values we saw being published up through Node-RED, the device ID, the timestamp, and the temperature. It's going to generate a new message that it's going to send back down, and there's a type in there. And remember, we said that if the temperature was over a certain amount, that the message type was going to be temp. In that case, we know it's a temp alert, right? And so this message here is what's actually going to end up getting displayed back here on the LCD when that happens. So kind of cool. Let's check back over here and see if the website is loading up fresh data yet. There we go. Cool. I'm now getting 11:56 a.m. and it's 11:57, so it probably just switched over on me. Cool. But there's my current temp values. And so if I did actually do something to increase the temperature here, so, well, in fact, let me plug my buzzer back in. I had unplugged it because it was extremely irritating. Plug it back into D3 here. So in fact, I can test the buzzer here. I added in some code here into the web application where if I push this button, again, I'm fighting my burdened internet here. This guy should get that. Sorry, the buzzer is supposed to be on D3. That's where I connected it. Okay. I didn't quite hear that come through. Hopefully that'll... Oh, there it goes. Okay, cool. Sorry, I think I'm just fighting really slow internet right now with me trying to publish and do all this stuff on it. So that's my bad. But I don't know if you heard that in the background, it did buzz. So the other thing then is if I can get that temperature now, it's already at 34. Here, this is just a little hand warmer here. I'm just going to drop that right on top of my temperature sensor, which is right here. And see if we can get that to go up. Well, there, it's already at 36. So at that point then, we should start to see temperature alerts coming back in through this. Cool, there it is, temp alert. All right, and that's because of that function. So that's kind of cool. All right, so that's overall, set up there. I've got, okay, now it's going to get really irritating. The temp's already at 38. So I'm going to stop this and bring that temp back down. Okay, so eventually that guy will stop buzzing, and if it doesn't, I can just unplug the buzzer again. So, but there it is, it's publishing those values, and if I were to refresh back over here, the web application, we should see some of those new values coming through. I've gotten at least a 40.9 coming through. There we go. So there's that 40.9. It jumped all the way up to 41, et cetera there. So I mentioned that I didn't implement the Power BI embedded piece. That's this chart. And again, if you're interested and you walk through that, if you get one of these nooks and you walk through this lab yourself, you'll set up the Power BI piece as well. So, all right, hopefully that'll stop buzzing here. So, well, what the heck? I'm just going to unplug the buzzer. We got it. Okay, cool. All right, so hopefully that sort of was a little enlightening. I know it's quick, got a lot to go through here. But let me jump back over here then and hit the last piece of this, and this is Azure IoT Edge. And so Azure IoT Edge is, as I mentioned, just recently renamed name for what we previously called our Azure IoT Gateway SDK. So as you're out searching the net now, you might want to look for references to both of those until everything sort of updates to the new naming here. But I think the new name really does a better job of indicating what it's for. This is about helping you do IoT at the edge, right? So much of IoT has appropriately been focused on the Internet of Things. And we think about pushing up to the cloud, and we sort of rely on the cloud to do a lot of analytics. Well, the problem that you have there is that sometimes the connectivity layer doesn't really support high bandwidth or it costs per message or something like that. And so if we can do more processing out at the edge across a number of devices, we can cut latencies down, because if there's analytics that can run on the gateway device and immediately communicate back to on the gateway, if there's analytics that can run on the gateway and immediately communicate back to the device without having to round trip all the way up to the cloud, we can cut that round trip latency down. And so that can be really important in scenarios where we have devices that are far more dependent on, real-time or near real-time analysis. The other piece is that a lot of the times, why send data if we don't need it? And so we can start to become more intelligent about what data we communicate to the cloud and when and all that good stuff. So the other issue that you have, and why gateways are important, is that not every device can connect to the internet. So if you take, probably the most popular, at least prototyping microcontroller that's out there today, the Arduino Uno, it has no network connectivity built in. There's no Ethernet. There's no Wi-Fi. It can't get to a TCP/IP stack without adding additional hardware. Yes, you can add additional hardware. That's not my point. My point is that this MCU by itself can't do that. You have to add additional hardware to it, right? And in fact, I guess you could say this isn't really an MCU, it's a dev board, right? Wrapped around an MCU, but okay. My point is not every board that you have can connect to the internet. The other problem that you have is that not every device has the compute power. Again, let's take the Uno as an example to do TLS and SSL. So it can't do that secure communication that, if you recall, going back to one of my first slides, Azure IoT Hubs requires. Remember, it was AMQP-S or MQTT-S or HTTP-S. There was one extra T there, HTTPS. We require that TLS or SSL encryption layer on there. And not every of those smaller, lower-powered microcontrollers can do that. And so that's where a gateway device comes in, right? I can take a low-powered or under provisioned device like an Arduino Uno or something even smaller or less capable, et cetera. And I might have many of those. I might have 10 or hundreds of thousands of them in a certain location. And if they want to communicate with the IoT hub, I need to stick something in the middle, right? And so that's where this sort of concept of a field gateway comes in. And having a device like the Intel NUC that has multiple connectivity options. It's got Ethernet, it's got Wi-Fi, it's got USB, it's got Bluetooth, but also has some compute power. I mean, this is running a full distribution of Linux. I can hook up monitors and keyboards to it and treat it like a real computer, and then I can tie it into my management schemes as well. But now those devices in the field can communicate with the gateway over local protocols like USB or Bluetooth Low Energy, or just good old radio or serial, or it might even be Wi-Fi, but maybe I don't want those devices going directly to the internet themselves. Maybe I need to keep them on a secure network. And so it could be just not just that they can't do Wi-Fi, but that we don't want them doing direct internet connectivity for security purposes. And then the gateway can turn around and do that secure communication with the IoT hub for me over those standard protocols. So that's sort of the idea there. And so what code do you put on the gateway? Well, that's where Azure IoT Edge comes in, right? So remember that the NUC itself has a Wind River Linux distribution already deployed onto it. But along with that, we have a pre-built Azure IoT Gateway solution. And then, of course, you could update that to some of the new Azure IoT Edge SDKs, et cetera, as they become available here as well. So the Azure IoT Edge is open source. It's all up in GitHub. You can browse up there and get to the SDK for it, documentation, samples, and all that kind of stuff, and start hacking away. There's also some new work going to try and streamline the development tool, because development flow. Admittedly, in the past, it's been a little forced. You're getting in and doing C programming, and you've got to understand some low-level BLE stuff, et cetera, if you're going to work with those layers. So we're trying to sort of raise the platform abstraction for you so that it makes it easier. We've got some NPM packages and some other things like that to help you get started. And so in my demo here that I've got to jump over to and get to quickly, I'm going to use another device. In this case, I'm going to use a TI sensor tag, which if you haven't played around with them, it's a really cool device. In this case, it's based on a CC2541 processor, but it's got temperature and humidity and barometric pressure and accelerometer and gyroscope and a whole bunch of other cool stuff on it. And so it just automatically publishes these values over standard GAT characteristics over BLE. And so the Nook then, with my Azure IoT Edge gateway running on it, can listen for those BLE messages coming off the sensor tag, wrap them up into nice AMQPS messages to ship them off to the IoT hub for me. So this is the flow or the configuration of my gateway. So at the bottom layer here inside an Azure IoT gateway is this concept of a broker. So this is built into the pre-developed gateway solution, is this message broker. And this is internal, meaning it's just within the gateway itself. And then you define through a configuration file multiple modules that you want to communicate through this broker and what their links are, how, what module source and what module syncs. And you can define multiple links. So in this case, I've got a number of modules. I have one that's listening on BLE for those temperature messages, specifically in this case, coming off of that sensor tag. And so this is actually a BLE module. I tell it what GAT characteristics I want it to listen for and what MAC address, what's the MAC address of the sensor tag that I want it listening for those messages from. It's then going to take that temperature data and send it through that message broker using a standard internal messaging format off to another module called the BLE printer. And this is just a sort of a debugging module. It'll basically take the message in and just emit the data out to the console for you so you can see the messages as they flow. It's also, though, going to send that same temperature data off through the message broker to a mapping module. And what the mapping module is going to do is it's going to take that MAC address for the BLE sensor tag and map it up to an IoT hub device credential. So if I jump back over to my portal here, there it is, sorry. The portal, and if I go back to the main page on my portal, you notice that I actually have another IoT hub that I set up here. And in that one, I've set up a device ID called sensor tag. And that sensor tag, now I could have used the same hub, it's just the message format is different. So, and I didn't have time to massage the message data to match. So the data flow that I have in the other one didn't match this. So I just sort of built my own sensor tag. And then if I look in there again, there's its own set of credentials, right? And so basically this guy maps up that MAC address to those credentials and then sends those off to the IoT hub along with the temperature data. And this module is what actually publishes it over AMQPS off the device. So I'm coming in over BLE and sending out over AMQPS. And then finally, there's a logger module that just logs everything off to the message file. So to play around with this, I'm going to use an SSH tool. And any SSH tool is fine, but I've got one called MOBA Xterm. And the reason I like this one is that it also automatically pulls up this SFTP window over here for me as well. And so here's the implementation of that BLE gateway. And all those modules and their linkages, et cetera, are defined off in these gateway configuration files. So the cool thing about this MOBA Xterm SSH is that I can just open this file up locally on my computer right inside Visual Studio Code. Sure I can. Let's try that again. There we go. Sorry about that. And so when that opens up here, gosh, I love live demos. All right, well, hopefully that'll pop up. This is a configuration file. It's just hanging on here. All right, well, we'll see it here. I'll just cat it out over here. So I'm going to just cat out my BLE gateway Bret.json file here. Cool. So you'll notice it's just a JSON file, and in here's all those different modules that we saw in that slide back there, right? So there's the one for the IoT hub that publishes it out. There's the one for the BLE printer that logs to the console. Here's the mapping one that maps the BLE MAC address of my sensor tag off to the device ID and credentials from the portal that I was trying to pull up back there. The sensor tag itself says, hey, here's my MAC address, and here's those GAC characteristics of those different temperature values that I can publish out here. And so one of those, I forget which one, I think it's this guy, is the temperature one. So it's going to read that periodically every second and send that data off through the message broker there. The logger logs everything out into a log.txt file. And then here's those links, right? So the sensor tag sends its data to the BLE printer. It also sends its data off to mapping. Mapping sends its new device credentials off to the IoT hub, and everything sends its message off to the logger. So that's my configuration file. So to run this guy then, I can just run the BLE gateway solution that's in there and give it that configuration file. There we go. And so this guy now kicks off, and I've got a, there it is, it's connected up. Let me get my camera up here. All right, so this is the sensor tag device, and it's reading the sensor data off. And on the screen, the one that we're interested in seeing is the left-hand one. That's the sort of the object temperature that's down there. This one that's on the left is a little bit of a, I think a conversion error that's showing up at 500 degrees. But let me come back in here. I'm going to drop this just hand warmer right on top of my sensor tag. We should start to see these temperatures are going up. Yep. So 27.3, 34, 375. So hopefully we'll move off, and it's going up, but a little bit slower. It's wrapped up inside this nice little plastic casing, and this temperature is actually the temperature of the chip, whereas the other one's supposed to be the ambient temperature that's coming out. So, but that's okay. We're getting this going up, and I can definitely see it crawling up there, 0.43, et cetera. And to see that they're actually coming up into the IoT hub, I'm going to use another little tool here. It's connecting up to that same hub that we just saw in the portal. But the cool thing about this is I can say, hey, watch for messages coming off that sensor tag. And so if I hit monitor here, I can start to see that, yep, sure enough, I've got new messages coming in here. And it's, I didn't have time to do the conversion here, but the data right there, that's just a hexadecimal, an ASCII character representation of the hexadecimal data, which is the temperature sensor data coming up through there. So I can see new messages coming in, and we're getting that data coming up. So, all right, well, I've run a little bit over time, but hopefully from there we've got a good sense of sort of, yeah, tons of documentation up here. I send you off to a URL that you can use if you want to play around with that BLE gateway demo that I had just there. One thing I will mention there, I think that if you get a sensor tag, the CC2650, the newer one, has a little more functionality and will probably work a little bit better with that. Mine's a slightly older one there, but still we saw working and publishing data up. Cool. All right. Well, sorry that I ran a little bit over there, but hopefully that gave you a nice overview of sort of the Microsoft Azure IoT stack. We took a look at the Grove IoT Commercial Developer Kit and how it can help you build sort of these solutions, either from a very simple, sort of Node-RED drag and drop style type interface, all the way up to, actually using, C libraries and gateway software, et cetera, to build more robust solutions out there. And then we took a look at Azure IoT Edge, which is our gateway framework solution there, and walked through an example of having it read a value off of a BLE sensor and then send it up into my Azure IoT hubs over AMQPS for me there. Again, my name's Bret, email address there on the slide, and you can use that ak.ms/IoT DevFest URL to grab the slides. And with that, I'll stop my screen share and jump back over to webcam and open it up for any questions. Question there from Neil: can I use this board for the Windows OS? Thanks. Yeah, this is my workshop out here. But as far as the board for the or running Windows on the Nook, I have not tried it, and I'm not sure whether or not Intel supports it. It's an Intel product, so that's probably something better asked of them. But my expectation is that yeah, you could put Windows down on it. It's it's an Atom-based processor out there, so you ought to be able to install Windows on it. I just haven't done it myself. And thanks, Peter. Again, if you grab the slides, and I'll make sure they're available on the conference platform as well, I point you off to a couple of those walkthroughs that you can do on your own. Question about the Grove kit. Let me see here. Yeah, the question on the Grove commercial kit is around whether or not it can run Windows, and I've answered that. I'm not positive. So I haven't done a whole lot with GPS, although I would say that there's a number of modules that you can add to existing devices. There's GPS shields for the Arduino and all that kind of stuff. And typically it really just comes down to being just another I2C device that you end up querying. So the overall mechanism for you working with it programmatically is no different than reading a digital temperature sensor or something like that. It's just the data you get back is lat lon rather than a temperature and humidity or something like that. So I know that's not a great answer, but no, I personally haven't done any GPS stuff other than on a mobile device like a phone where it's part of the SDK and the GPS is built in. What are you looking to do with it? Yeah, that's a big space. Lots of folks, putting trackers and that kind of stuff. And if you haven't seen the Adafruit feather boards, they are another simple prototyping, platform like the Arduino Shields. They're a little smaller form factor, and they have their own sort of module edition, solution called feathers. So there's feathers for driving motors, et cetera, and they have a GPS feather. And so you can get a relatively small package that has, a feather like the Adafruit Feather M0, which is a SAMD21 processor on it, and then Wing 1500 Wi-Fi, and then you add in their GPS sensor feather, and so you can kind of stack them up and get something that's probably about the same size as maybe my sensor tag type stack there. If you pictured two boards stacked together or something like that, you could get something relatively small. Question around how many devices connecting to a hub. It's one of those lame answers. It's going to depend on how fat that data is and how often you're communicating with them. The NUC itself is not an overpowered device. It's to help keep the cost low and heat and all that other good stuff. It's a relatively small form factor, but it also means it's relatively small power on the compute side of things. So you can't throw a ton of data at this simultaneously. You might also run into some signal congestion issues depending on your protocols, et cetera. But I really can't answer that without more specifics around. Well, I probably can't answer it without actually implementing a test and getting a feel for it. So yeah, Mary. Every few minutes from a device. Not a problem at all. In fact, here you saw I was pushing, temperature sensor data every second up there, which, it was no problem at all for the NUC there. If I had 100 devices all pushing data at 10, every second, I would bet it could probably still handle it. But if I was getting up into the hundreds or thousands, I might want to make sure that I've tested it and made sure that it's going to work for me out there. The other thing that I always talk about with IoT, and I'll just mention it here as well, is that a lot of people, and it sounds like Mary, in your case, you agree because you're not sending data constantly. A lot of people think they need real-time data. I'm sitting out here in my garage. There's absolutely no reason for me to know what the temperature in my garage is every second. That is just way too much data. Knowing what the temperature in my garage is every hour is probably enough, right? Maybe every half hour, but any finer grain than that, come on, what's the point? What are you going to do with that data? Now, flip side, if I'm a CNC machine on a factory floor and I'm using my telemetry data to indicate, production errors, then yeah, I care a lot about real time, et cetera, out there. So it depends very much on the scenario, but in most situations, we don't need real time data. So cutting back the amount of data that you send and how frequently you send it is typically going to help you overall throughout the entire architecture. All right, folks. Well, it looks like we're over the hour here, so I'll give you some time to jump off and get to your next session. Again, thank you very much for your time today, and enjoy the rest of the conference.